Good, thank you. Timing though. It just started. Okay. Now, Caitlin, I said to the class, I posted something on the Google Classroom. This is called circular functions. By the end of the today, Nick, if you go to attack it, you can solve every problem. Okay. Now, we are just going to start today by starting the concepts of the circular functions and now talk about the symmetry. Now, let's start by this topic. Let me, where is that? Let me write it. We are going to talk about the circular functions. Now, before I specifically talk about the circular functions, we are just going to start by a basic things that we have done so far. So far, what we have talked about, we have talked that if that's going to be a Cartesian plane, x, y in 2 dimensions, we said that we can localize any events in that Cartesian plane. By localizing, what do I mean? For example, I talked that mosquito is just moving around. You can, at one instant of the time, you can localize it, say that, okay, it has an address with x and y. However, we said that it's not going to be enough for us. We are looking to something different, to have a complement to that, to making something more useful. And in order to make the things more, I should say, localized, to finding the locations in the space. Because it's very important for us as you move on to the higher levels, it's very important to localize stuff in the space. I do not mean about the time, just I mean localizing that into the space. Then as a result of it, what did we say? We say that, okay, then if that's going to be the purpose of localizing the stuff on the plane, I'm going to introduce a circle inside, I should say, the Cartesian plane. And we said that, okay, in that circle, the thing which I'm going to consider is that the radius of that circle is going to measure as 1. For example, if that's going to represent the radius, or we are just going to say that the radius is going to be 1 unit. And also, the other thing that we discussed was this, that we said that any events has to be confined on the circumference of this unit circle. You have no events taking place outside of that unit circle, and you have no events taking place inside that unit circle. Everything should happen just on the circumference. If that's going to be the case, we said that we can introduce another measures. We said that if this is going to be representing the mosquito, that we just localize that while it was dynamic and moving into that point, which is represented by x and y as a Cartesian plane. We said that also, beside from this, we can also locate and localize that mosquito with an angle, as I call that alpha. What did we say? We said that, okay, that the same mosquito is going to be represented just either by this pair of x and y, or you can say that, okay, it can be represented by, for example, m as also cosine of the alpha and sine of the alpha. You see that there are 2 different methods to represent one reality in the Cartesian plane. Now, based on the thing also that we learned the session before, we said that because that's the unit circle, it means that the radius is 1. We talked about the arc length. We said that the arc length, if I represent this piece of the arc, which is starting from point A to point M, I call that AM as an arc. We learned that the arc is going to be what? It's going to be, we learned that in geometry, the arc length is proportional to the angle, to the center angle, which is looking at it. We said that the AM is proportional to the alpha, and the constant of proportionality was the radius. However, we said that we have to be extra careful that the alpha that we are talking about here has to be measured in radians. Otherwise, you are screwed. You cannot find that relationship. Now, in the unit circle, we said that the radius is how much? Is 1, and that's the name of it. Unit circle is that the circle that has a unit 1. Then as a result, from this unit circle, we can say the length AM, the arc AM, which is equal to the S, which I have it here, can just be equal to the alpha itself in radians, because R is 1. Then as a result, that's the concept of the circular function. Then we say what? We say that because if you look into that, you see that the length of the arc, which is S, is equal to the angle, which is alpha in radians, as long as the radius is 1. Then instead of saying, for example, cosine of alpha, we can say that it's going to be equal to cosine of the S. Then you see that in the unit circle, the beauty which it has is that the trigonometric ratio is going to be defined not only for the angles of the central angles, but also they can have the same representation with the arc which they are looking at, because the arc length is proportional to the center angle. As a unit circle has a radius of 1, then the alpha and S, they are always going to be equal. Then the cosine of alpha is the cosine of the S. And that's true for the other trigonometric ratio. We can say that also the sine of alpha is equal to the sine of S. You see that S and alpha, because they are the same, and we deduced it from. That's the concept of the circular function, which they show up in the unit circles. Now, any questions so far? Yes.
I don't really understand why x is cos of alpha and y is sine of alpha.
Oh, okay. This one. Look at this. We said that when we define the trigonometric ratio, we said that, wait a minute. We were trying to localize this moving mosquito on the circumference of the unit circle by x and y. But we introduced another parameter, another changing parameter. This is alpha. And our purpose was that to connect these two things together, to connect alpha, which comes from the unit circle, with the x and y, which it comes from the Cartesian plane. We try to reconcile them. How did we do that? We said that if we have the alpha, we can define cosine alpha by this definition. Cosine alpha is going to be the adjacent of the alpha. What is the adjacent length? This measure. How much is this measure, Ash? We are on the x-axis. The point M is here. We project it along here. We see that this represents what? X. Am I right?
Yeah.
That's right, because that's the origin of the plane. Then we said that we say x over, that's a ratio. The cosine is a ratio. X over what? The hypotenuse. This is the hypotenuse. Am I right? Which is R. That's right. Because R is 1, it becomes just simply X. And also the same thing for the sine alpha, which becomes the opposite. The opposite is going to be this, which is Y over R, which is Y. And that's the reason, guys. You see that instead of X, I showed that with the cosine alpha. And instead of Y, I was able to show that as the sine alpha. Does it make sense, everyone? Then for one reality which happens in the Cartesian plane, you have two methods to represent it. Now, I'm going to use now the same concept of the circular functions and the symmetry to derive some of the very important things. And let me also plot this. Okay. Yes.
I also don't understand why you said that the arc is equal to the angle.
Or, oh, okay, I'm gonna go back to that slide to talk about this. Look at this, Nick. We said that the arc length last session, the arc length like AM, which is at the intersection of the X.
Sorry.
That's right. Because R1, then as a result, the arc length is equal to the angle itself.
What does S represent there?
S represents the area here from the arc from A to M.
Oh, so AM and S is the same thing?
That's right.
Oh, two fingers.
AM is the arc, S is the length of the arc. Look at that AM, look at that the curved line. It means that AM is a curve, is the arc because it's a curvature up there. And its length, for example, it's 2 meters. Its length is S.
Okay.
Right? Awesome. Now, any other question, guys? Have you ever happy so far? Now, we go back to the Cartesian plane crossing the unit circle. It becomes like the GPS, that it finds the address for any events in the universe. We say that, okay, I'm going to do what? I'm going to localize one event. For example, look at this event. Yes. So, of course, please do so. The session is recorded. Please feel free to watch it anytime. No worries, Caitlin. Have a nice day. Thank you. Now, what else did we say? We say that, okay, for example, something happened in the universe. We call that M. We have been able to localize it on the Cartesian plane by the coordinates of X and Y. We know that both X and Y is the coordinates of the M. Now, the thing which happens is that now, because we are exploring one property of the circles, they have a very interesting property that they have symmetry. Am I right? For example, if you have a circle, if you cut it, for example, in 2 halves, you can just, match them on top of each other. That's the property of the symmetry. Now, we are going to use that symmetry as a property of a circle to locate other points. What does it mean? It means that, guys, sorry, it's not a very good example that I'm using. Sorry about that. It's a little bit aggressive, but imagine that you are going to hunt some birds. You have, for example, a stone. You pick up a stone from the ground. Sorry, guys, that's a very bad example, but I have no choice. You pick up one stone from the ground. You see one bird on the top of the tree. You draw your stone, and instead of, sorry to say that, killing one bird, you see 4 birds fall down. You see, oh my God, I used 1 stone, but I got 4. And now that's the thing which we are going to do with the symmetry of the circle. We say that we are going to use 1 stone. It's going to be the point M, which we have been able to localize it with some certainty. We have some certainty that that event is localized at X and Y. It becomes this stone. I'm going to draw it to kill some birds. Sorry. Now, what happens? Look at this. I see that, okay, if I use the symmetry, I draw this line, which is parallel to the X. And it starts, I should say, from M, and it's parallel to the X axis. It crosses the other part of this unit circle. Now, which I'm there, I see that, okay, that stone killed the second bird. And that's this bird. I'm going to call that M prime. Why I call the second bird, we just killed it? Because we know that we just draw one stone, and this point, without measuring its localization, we can readily say where is that located. We said that, okay, the axis is gonna be symmetrical. We call that x is gonna be minus x. And y, look at that, they share the same y. They have the same y. You see?
This is M prime.
Sorry, what?
This is M prime.
M prime. It's gonna be the second bird. You draw your first stone. You draw it to the tree. That's the second bird which dropped from the stone, from the tree. And that's it. Now, the other thing which I'm gonna do, from this point, I draw a parallel line to the y-axis. Make sure that it's gonna be parallel. When you draw a parallel line, you reach another point, which is the intersection of this parallel to the y-axis and the unit circle. I'm called that M double prime. Let's call that the second bird. The first one was the first bird. That's going to be the second bird because double prime. This point, you see that they share the same x's because they have the same projections along the x. Then as a result, x is still minus x. And y, you see that it's now below the zero. It becomes minus y. Then what's the case for this? It means that if you know what is the M, the first bird that you killed, you can localize M double prime on the third quadrant without measuring anything. You measure nothing and you got the identity. I'm going to give one example with numbers, then it should make more sense. And now I'm going to draw from M double prime a line parallel to the x-axis. It crosses this unit circle at another point, but be careful, I do not pass the unit circle because we know that outside of unit circle, there is nothing interesting happening. Everything should happen within the circumference of that circle. That's why I do not keep continuing, I should say, that line at the intersection. That's an interesting point. This point is going to be M triple prime. And the good thing is that you see that the x, you do not measure, you call it from the second one, from the M, and y, it's below the y, below the zero, it's minus y. You see that the third bird is killed. From the first one, you got the third one. Then at the fourth quadrant, there is no need to measure the M double prime coordinates. It's given from the M. And also from here, I go back, I just, there is undo. You see also from M double prime, I parallel line to the y-axis. It gets me back to the M, and I get to the same point. You can repeat the same thing infinite number of the times because there is no constraint, and always come to M prime, M double prime, and M triple prime. And that's the thing. Now, any questions so far? Then we got the concept of killing 3 more birds with 1 stone. We know, but what's the philosophy? We know the localization of point M with certainty, and without measuring M prime, M double prime, and triple prime, we can identify the other birds. Now I'm gonna, on the same slide, before I just go to provide some numerical numbers, yes, of course, please. Before I just go to come to describe, I should say, some numerical example, I'm gonna identify how to find the angles from here, because so far we have been doing some storytelling, not much of the math has been happening. Now, look at this. From here, in order to go to the M prime, I'm gonna make this angle. And always remember, the angles that we are making has a fixed arm. The fixed arm is always what? The fixed arm is OA. It means that OA is the fixed arm of an angle, never moves. It's always fixed there. You have a glue, you pasted it there. But this is the OM or OM prime, that's the moving one. Now, look at this one. If I know this angle, let me color code everything. If I know this angle, the blue one, is alpha, what is this angle? This is, because we are working with the radians, we call that pi minus alpha. Then you see that if you have the first angle, which is alpha, can be 30 degrees or pi over 6 radians, you see that the angle which comes with the same characteristic happens at pi minus alpha, which is located at the second quadrant of the Cartesian. It's very, very important. Guys, now we are talking some very serious stuff. These are very serious. Now look at the other one. We say, okay, now I'm gonna build another angle. The other angle connects O to the M double prime, then the fixed arm is AO, the moving arm is OM double prime. What is the angle that we are cutting from here? Look at this. This is the angle that we were cutting. This angle happens at the third quadrant. And the measure of this angle, if this is alpha, look at that. Alpha, the blue angle is becoming my reference. I mean, from the reference, I go to the third quadrant and I say the angle, which has the same characteristic of M, is pi plus alpha. You see, the red angle is pi plus alpha. Now, let's build the last angle, which connects me to this point, M triple prime. OA, again, is the fixed arm. OM triple prime is the moving arm, which means that this angle, the black one, which takes you to the fourth quadrant of the Cartesian plane, it takes you to the M triple prime from the M, which is what? Which is 2 pi minus alpha. And this is the first quadrant. Now, guys, to sum up, everyone please listen. To sum up, you see that. Nick and Ash, please listen. This is a very important thing which I'm going to emphasize on it before we finish this part. To sum up, what did we say? We said that we have one point which is localized. We bothered ourselves. We went to the field to measure this. We got the values for X and Y for the M. Without making any measurements, you can sit home, do not go to the field to make the measurements. You can find these angles, pi minus alpha, pi plus alpha, and 2 pi minus alpha, which has a characteristic relationship with the same M that you measured. Then you see that for one angle, you had to go to the field, you bothered yourself to measure, it was a rainy day, such a hard thing. For the rest of it, you stay at home and you use these characteristics to find the measurements. Isn't that cool?
Yeah.
Yes, Daniel, isn't that? You just arrived. Now, I'm going to move on to give one example. That what did I mean by it? Let me do this. Let me do this. Let me put the circle like that. We have X, Y, and we have the origin. Now, the thing that we do is this. We say that, okay, let's localize one event here. Let's localize one event there. And let's find a measurement for this. Let's find a measurement of pi over 6 radiant. And welcome to the world of using radians only for the angles on the unit circle. Pi over 6 radians, which is equivalent to how much in degrees? 30. How do you find? Put it in mind. Pi is representing 180. 180 divided by 6 becomes 30 degrees. Now, look at this. Look at the point M. Something is happening. The universe is localized at point M. We want to measure that event. Based, what is the X and what is the Y of pi over 6 in this unit circle? Guys, look at this. I'm gonna ask a very interesting question. For this event M, we have two coordinates representing this point. And that's why I put the question mark there. What are those points? How point M is represented when the angle is pi over 6? Sorry, what? Yes, that's right. And now, look at this. We know that logically, because based on this slide that we have, we said that M comes with an X and Y. Look at this. X is cosine alpha, is cosine pi over 6, and Y is sine over 6. Why? Because if I come also here, look at this point, the projection along the x-axis. Look at this projection. This value which I have here, which is the x, because it's on the Cartesian, the distance between the origin and the x is what? We know that x, let me write it like that. We know that the cosine of any angle is x over r. Then as a result, x is what, guys? R times cosine of alpha. R is 1 because we are still working on the unit circle. Then if R is 1, then as a result, x is equally to cosine alpha. Here, we just solve this one, then we take a break. If you are getting tired, then when we are feeling refreshed, we come back again. Then as a result, the value for the m here has to be cosine of. The value as alpha is pi over 6. How about the y? For the y, we define the sine alpha like that. Sine alpha, it is a definition. For example, how do you define the school? You say the school is a place that you just go to study. You cannot find that, change that definition, and I cannot change the definition of the sine alpha. It's always y divided by the r, which means that then as a result, y is r times sine alpha. Because r is 1, then y is equal to sine alpha. Then here, the value of the y becomes sine of pi over 6. But if you tell me at one point of time that cosine pi over 6 and you do not continue, I should be so surprised, because pi over 6 is a kind of a celebrity in the trigonometry. Who is your favorite celebrity? For example, Jennifer Lopez, huh? For example, pi over 6 is like the Jennifer Lopez in the trigonometry. Everyone knows her. Pi over 6, everyone knows her. How much is the cosine of pi over 6? Huh? Yes, pi over 6 is 30. But how much is cosine of 30? Huh? 150. Okay. Did when I was sick at home, I think you talked about the right triangles, huh? Yes. And you talked, you said that, for example, look at this. Guys, I'm gonna go back to this slide. The purpose which I'm gonna do this part is that I'm gonna find the numerical values for cosine of pi over 6 and sine pi over 6, which is essentially cosine of 30 and sine of 30. Now, what I'm gonna do is this. Let me do this. Let me do this. Let me do this. What is that, guy? Triangle, right triangle. Nick, it's a very important part. Now, this is a right triangle. We say that in this right triangle, I never memorize myself the sine of 30, cosine of 60, cosine of 45. These are very important, I should say, angles, the most popular celebrities. I never memorize it because I forget it. I may forget it next month. That's how I remember it always. For 30 and 60, I think the other teacher, when I was sick, they worked on that. They said that, for example, if this angle is 30 degrees, how much is the share for this angle? 60. Because 60 degrees plus 30 degrees plus 90 becomes 180. I say that if I make this length of the hypotenuse 2 and I make the length 1, this one is going to be how much? What is that question mark? Pythagorean theorem. Look at this. A Pythagorean is this. A, B, C. You say B squared plus C squared equals to A squared. I have this person here. I call it A. A squared plus 1 equals 2 to the power 2. Then as a result, A is going to be how much? 1.
Really?
Yes, look at that. You have A squared plus 1 squared should equals 4. Then you have 4 minus what? Look at that. I made a big mistake. It's going to be square root of 3 because 4 minus 1 becomes square root of 2. Now, square root of 3. I have it here. Now, let me erase this. Guys, please look at from this part. I hope that you can be able always to produce the same thing which I'm doing right now, because I never memorize myself these angles. I always drive it like the one which I'm going to do right now. Look at this angle. You are looking for the 30 pi over 6. 30 pi over 6 radian is equal to 30 degrees. Am I right? Then as a result, it is represented by this angle, 30 degrees. Now, in the right triangle theory, which the other teacher, when I was at home and sick, she talked about this. She mentioned that the cosine of 30 is how much? Is the adjacent of that angle over the hypotenuse. That's right. We say that then adjacent is the square root of 3 over 2. This is always, I remember how to drive them. I always make sure that I can reconstruct a triangle which the hypotenuse is 2, the other angle, the other length is 1. You can use the Pythagorean theorem to get the other length as the square root of 3. Then you use the basic definition of the cosine and sine to find the numerical values. And as a result, you can say that also the sine of 30, how much is that? Opposite over the hypotenuse. That's right. The opposite of 30 angle is what? 1 over, what is the hypotenuse? It's always 2. Then the sine is going to be 1 over 2. Then I hope that when I see you, for example, next time at the cafeteria, and I ask you how much is the cosine of 30, if you cannot remember it right away, you are able to produce the same thing and take 1 minute, but at the end come to the answer. This is very important. Now, if you are curious, you can say that, okay, how about the angle 60? What is the cosine of 60? Hypotenuse, which is 1. Sorry, adjacent, which is 1, over the hypotenuse, which is 2. And the sine of 60, 60 is this. What is the length in front of it? Square root of 3, opposite over the hypotenuse. Then you see, oh, look at that. How interesting is this? The cosine of 30 is equal to sine of 60. And at the same time, sine of 30 is equal to the cosine of 60. We are going to see why in the coming sessions. We are going to have some identities of the complementary angles to show that why it's happening. Then as a result, if I go back, we see that this point, guys, M is going to be represented as cosine of pi over 6 becomes how much? Square root of 3 over 2. And the sine is how much? 1 over 2. Now, look at this. I'm going to do the same thing which I did before. I say, what happens if I use this symmetry? I come to this angle. And now everyone, please listen very carefully. We need 3 more minutes, then we take the break. But these 3 minutes, say what? Oh, no problem. But please, Nick, please make sure that you watch the video from this part. Yeah. It's very important. And have a nice evening then. Thank you. No problem. Thank you. And guys, look at this. What is the angle here that I got to this point M prime? I'm at the second quadrant. What is this angle? It's pi minus pi over 6. Why? Because we showed that here. From here to kill the second bird, we are pi minus alpha. From alpha here, we go to pi minus alpha. Then as a result, this angle here is 5 pi over 6. Now, that's right, 30 plus 90, 120. But remember, Daniel, we focus all from here, we always focus. We prefer the radians because we get used to it. But 120 is perfect. Brilliant answer. Thank you.
I think I may be wrong. I don't think it's 120.
Look at that. This is pi over 6. This is 30. And this is 30 also here. And they are 90, and that's 120. You can also, you can put 5 times 180. How much do you get?
5 times 180.
I think 130 is going to be. Anyhow, no worries. We do that later. How much is that? They divided by 6. 130. Something like that. Yes. Anyhow, we focus on pi, 5 times pi divided by 6. 150. Okay, thanks. 150. Now, then we have here 5 pi divided by 6. This is the angle, which is the concepts that we talked about. This is going to be the second verb that has the same characteristic. Then the coordinates of m prime is how much? It's going to be minus square root of 3 over 2 and 1 over 2. You see, I didn't measure anything. I used the symmetry. I got the second verb. Now, let's move on to the next one. I move right away here. I draw a parallel line to the x-axis. And I make that angle here. You see that the angle that we have here, how much is from this angle? This is, that's right, pi plus pi over 6 equals to 7 pi over 6. Why? Because in this slide, we said that if the angle is built from the symmetry at the third quadrant is pi plus alpha. Its coordinate is minus x and minus y. Then it means that this point for us here is minus the square root of 3 over 2 and minus 1 over 2. You see, for this point, m double prime, I didn't need to just find any values. I just used the symmetry and I stayed at home and I didn't go to the field to do the measurement. Now, the last thing that before we go for the break, we say that, okay, look at this. I do the symmetry again, parallel to the y-axis. I cross the circumference and I make this angle. It becomes my m triple prime. The angle is this. All the way comes here, which is 2 pi minus pi over 6, which is 11 pi over 6. You see that then m dot triple prime for the angle if is 11 pi over 6 is square root of 3 over 2 because the axis remains the same, but the y it's just below the origin. That's why it becomes minus 1 over 2. Then as a last point that we take the break, you see that we just started with 1 point m at the first quadrant. It was pi over 6, which was 30 degrees. We had to just have our gloves, have our safe hat. We just go to the field to do the measurement. But for the other points, m prime, m double prime, and m triple prime, we stayed at home. We had the cup of coffee. We did the measurement by using the symmetry. Then as a result, guys, what is the cosine of 11 pi over 6? Look at this. The cosine of 11 pi over 6, 11 pi over 6 is this angle. The coordinates is this. The x value of the coordinate represents the cosine. Then the cosine of 11 pi over 6 is the square root of 3 over 2. And that's the beauty of this. On the exam, you may have something like that. What is the sign of 11 pi over 6? You say, I haven't seen 11 pi over 6 before. And you have to use these symmetries to go back to the reference angle. You see that, okay, it is connected to the pi over 6. And that's why the cosine it becomes this. Yes?
So is 7 pi over 6 negative root 3 over 2?
Yes, the cosine of 7 pi over 6 becomes minus the square root of 3 over 2. You see, Ash, you have one angle, then use symmetry because you make infinite number of the angles.
Okay.
Beautiful, huh?
Yeah.
Thanks for sharing that idea with me. Who wants to have a break? Of course. Then please enjoy the 5 minutes break. Come back by 3:45. Then we move on from there. Okay, let's see how my friends are doing at home. Okay, Michelle and Jackson.
You get the
You
diploma anyway.
You get it anyway.
February 15th was the last post.
Yeah, the certificate, you do not need to just go for the competition.
Yeah, there's no email, so it's just
Yeah, but that's a very valuable thing.
Yeah, Medina, I don't get this today. Yeah. Check your email. You got Microsoft Teams. Outside. Yeah. Thank God. Oh. No, it's actually like there was this one podcast on like schizophrenia or something like that. That's that one. Like that really started talking about like pathways.
Yeah.
The different neurons that like activate the amygdala on this part. Yeah. Do you guys go to like the midterm one? You go to that? I went to that for 5 minutes.
Me too, yeah.
And I thought it was late. Because like there was having introduction. And then I realized it was midterm.
What did they do with that?
It was really just like 5 minutes and you would like do like a recap with like each person. So it'd be like, do you have any questions? No one would have questions. And then you just sit in silence for like 10 minutes until the next day.
Okay, guys, I have a very interesting activity for you for the remaining of the class, which we have 10 minutes. I'm gonna give you some events which took place in the universe. We call that M as usual, and we say that we using the geometry we measured the angle which represents that incident is pi over 3 radians. It's roughly how much in degrees? Pi 60, that's right. Pi is representing 180, then 180 divided by 3 becomes 60 degrees then. There are two equivalents. Then I'm asking you, do the same thing which I did here on this slide. I went to the field to measure one incident. Then I got back home, I just relaxed, I made another measurement using the symmetries, and do the same thing, please. And remember also this right triangle that we find for 60 degrees and 30 degrees, the sine and cosine. Please do the here, come here, and do the exact same thing. Oh, you find, yes, you have one stone, Ash, you draw it to the bird, to the tree, you got 3 more birds. Now, that's right. And because the universe is symmetrical. Now, guys, now do this one here. Then we have almost 9 minutes. And I'm gonna pause the recording